In this video, we're going to take a look at section 5.2, which is on adding and subtracting rational expressions. Before we get to that topic, we have one thing we have to get out of the way first, which is how to find a common denominator, which is also known as the least common multiple of the denominators. So to find a common denominator, to find a least common multiple, for these polynomials anyways, what you're going to want to do is factor everything first, then take each factor that occurs and raise each one to the highest power that occurs. And you'll multiply all that together, and that'll become your common denominator, or your LCM. So let's practice finding the LCM. So for these problems, the factoring is already done for us. So step one, factor everything. These things are already factors because they're already being multiplied together. So there's no factoring for us to do. We already have our factors. The factors here are 15, c to the third power, b to the second power. The factors here are 3, c to the sixth, b to the fifth. And the factors here are 10, c squared, b to the fifth power. We will deal with the numbers separately from the variables. So let's do the variables first. Surprisingly, this is going to be easier than doing the numbers. So, a lot of times we have that impression that, algebra is hard because it's all letters and everything, and that's difficult to deal with. But in this situation anyways, the numbers are more difficult to deal with rather than the letters. The letters are very easy, especially since it's already factored. So to find the LCM for these variable factors, we'll take each factor that occurs. We have c as a factor. Now it happens to be in all three of them, but that's not a requirement. You take each factor that occurs. Even if it just occurs one time, it needs to go in your LCM. So c is a factor that occurs, so I'll put that in my LCM. And b is a factor that occurs. Now again, it happens to occur in all three, but that's not a necessity for it to be in the LCM. As long as it happens even just one time, it needs to be in the LCM. And then you raise each one to the highest power that occurs. So the highest power of c, we have 3, we have 6, and we have 2. The highest power is 6. And so that's the power that I want to use in my LCM. For b, we have 2, we have 5, and we have 5 again. The highest power would be 5 in that case. And so for the variables, that's the least common multiple. What this actually is representing, I know it can be a little complex, and if it doesn't quite make sense, I'd say probably don't worry about it too much. But this is the smallest expression that can be evenly divided by each of these variable expressions. So the c to the third power b squared divides evenly into this. So does c to the sixth power b to the fifth power. That divides evenly into that. In fact, it's the same thing, right? So it divides into itself. And c to the second power b to the fifth power also divides into this, right? So each of these will divide evenly into this, and it's the smallest expression with the least number of powers that meets that criteria. All right. Now for the numbers, we're looking for the same thing that I just mentioned. We're looking for the smallest number that can be divided by 15, divided by 3, and divided by 10. Be careful how you think about that, because almost every semester when I bring that up in class, people get it backwards. I'll say, well, what's a number that can be divided by 15? And they'll say 5. And that's not the case. 5 divides into 15, but 5 cannot be divided by 15. So I know it's a slight change in terminology or in phrasing, but it makes a big difference. It's completely opposite. We're looking for numbers that can be divided by 15, like 30, 45, 60. These are numbers that can be divided by 15 and also divided by 3. And all of those numbers can also be divided by 3, right? If it can be divided by 15, it can be divided by 3. So 30 can also be divided by 3. And also numbers that can be divided by 10, which would be 20, 30, 40, 50. And we want the smallest number that can be divided by each of these 3. And so we already kind of mentioned it, the answer, it's 30, right? 30 can be divided by 15, 30 can be divided by 3, and 30 can be divided by 10. And so that's the number that I'm going to put here for the LCM, for the numbers. If you have trouble determining what that number should be, you could also do it this way. You can make a list of the multiples of each of these numbers. The multiples of 15 would be 15, 30, 45, 60, etc. The multiples of 3 would be 3, 6, 9, 12, 15, 18, 21, 24. I feel like I'm going to skip one if I go too fast. 27, 30, 33. It goes on beyond that. And for 10, it's 10, 20, 30, 40, 50, 60, etc. So you make a list of the multiples of each of these numbers and find the smallest multiple that's shared in common. That's literally what LCM means. It's the least common multiple, the smallest multiple that's shared in common. And it's going to be 30, right? 30 is on the list for 15, 30 is on the list for 3, 30 is on the list for 10. It's the smallest number that they all three share in common. I ran out of room here, but eventually for 3 it would get to 60. 60 is another common multiple, but it's not the least common multiple. So 30 would be the least common multiple for the numbers. And so that would be my LCM, which incidentally would be the common denominator for these. So if these were denominators in a fraction, if it was like 1 over this plus 1 over this plus 1 over this, if I was trying to add these three fractions together, this would be my common denominator to do that, which is something we'll get to later in the video. All right, so let's take a look at another example. So here what we're going to have to do to find the LCM is the first step is you have to factor. You need to know what your factors are before you can determine the LCM. And I'm just kind of my shoulders are kind of slumped here a little bit because these do not look like very fun things to factor. They look pretty tough, but it's what we have to do. So let's go ahead and start with this one. And because a is not equal to 1, we can't use the shortcut. We either have to do trial and error or we have to do the AC method. And we kind of stuck with the AC method through chapter 4, so that's what I'm going to do here. So a times c in this case would be 2 times negative 56, which is going to be negative 116, if I'm not mistaken. No, that's not right. Negative 112. Excuse me. Negative 112. B is negative 9. So we need two numbers that multiply to negative 112 and add to negative 9. So you think about it for a moment. I'm not coming up with anything. So my trick for trying to find numbers that meet this description is I go back before I multiplied to get 112, where the numbers were slightly smaller, they're not much smaller, and I split these up in a different way. So for 56, I'm thinking, okay, that could be written as 8 times 7. And then I recombine these numbers to get different numbers to look at. So for example, I could take the 2 and the 7. 2 times 7 would be 14, and then the 8 would be by itself. Now, do these numbers somehow give me 9? No, they don't. So that didn't work out. Let's try to regroup it this way. We'll take 2 and 8 together, which is 16, and then the 7 would be by itself. And this actually does give me 9 if I make the 16 negative, right? Negative 16 times 7 gives me negative 112. It's going to because it came from these numbers here. And then negative 16 plus 7 is going to give me negative 9. So negative 16 and 7 are the two numbers I'm looking for. So what we have to do is rewrite the negative 9r as negative 16r plus 7r. Right? And so I'll still have 2r squared in front. I'll still have minus 56 as the last term. And again, that's a 16 there. I'm sorry I didn't draw that very well. And then we're going to do factor by grouping. So I'll group the first two terms together. 2r squared minus 16r. I'll group the second two terms together. Factor out the common factor in the first group. That's 2r. It leaves me with r minus 8. Factor out the common factor in the second group. It'll be 7. That also leaves me with r minus 8. And so this will factor as r minus 8 times 2r plus 7. All right, so that's how the first one factors. So that's the first one only. So we haven't even finished the first step yet for this problem because we have to also factor. Oh, let me just redo that. Sorry. Okay. Let's try one more time. 7. Okay. Let's do the same thing with this one. Now, I'm not going to actually work out the details of this because I'm running out of room. And as I've complained about several times on these videos, if I write too much stuff on the screen, it really starts to get laggy where I'm not even able to write things down reasonably. I have to go really slow. And it's a repeat of this exercise. So you do the AC method again. You do the factor by grouping. Another thing, and that's one way you could factor it. But with these problems, very often they will repeat factors. It's very unlikely that I get two completely new factors here that I haven't already seen. If I already did one factoring, this one should likely share something in common with it. The 2r plus 7 is out of the question because there's no way 2r multiplied to anything would give me 7r squared. So that can't be one of the factors. So I'd put my money on this one, r minus 8. I bet that's one of the factors. Now to get 7r squared, the other factor would have to have a 7r here. So r times 7r would give me the 7r squared. And to get the plus 8, I'd have to have a negative 1 here. Negative 8 times negative 1 would give me plus 8. Then I need to check to make sure if I FOIL this out that I get the negative 57r in the middle, and you do. So if you want to check that, you can see it actually does work out. You could also get the same answer using factor by grouping, so I'll leave that to you. The last one here is the a squared minus b squared formula. Hopefully you've seen this enough times already in chapter 5, you're really getting the hang of this. This will factor as r plus 8, r minus 8. All right. So that's step 1, is getting everything factored. So now I can see what all my factors are. Step 2 is you can start putting the LCM together by taking each factor that occurs. It doesn't have to be shared in common with anything. If a factor occurs anywhere in your expressions, it needs to be in the LCM. And so what are the different factors that I can find here? Well, r minus 8 is one of the factors. In fact, it occurs in all three of them, but that, again, that's not a requirement for it to be in the LCM. 2r plus 7 is a factor that I see here, so that also needs to be in the LCM. It only occurs one time, but if it occurs at all, it has to be in the LCM. 7r minus 1 would be another factor that I see here, and then r plus 8. And the order you put these in doesn't matter, so you can put them in whatever order you want. That shouldn't have any effect on whether you get the answer right or not in Math Excel. And then the last step, which really doesn't apply here, but I still like to emphasize it, is you raise each of these to the highest power that occurs. But these are all to the first power. Every factor we got here was just to the first power, so all of these will just be to the first power, which means this is my final answer. So this would be the LCM for these three expressions. This would be our common denominator if these were the denominators that we were dealing with. All right, let's take a look at one more example of this type. And so let's go ahead and do this one the same way. We'll start by factoring. And this one, there's not really a whole lot of factoring to do here. It looks kind of scary, but we have a common factor of z. And the highest power that I can factor out is 4. That's the most they share in common. So that's the greatest common factor. That's going to leave me with z squared, right? Because I have 6 here. I'm taking out 4. I'll have 2 left over. Plus 4, because I'm taking away 4 powers of z. So just the 4 will be left. And then z squared plus 4 does not factor. This fits the a squared plus b squared formula, whatever you want to call it. I don't know why I say format, but it fits the a squared plus b squared structure. And a squared plus b squared does not factor. So that's it. Can't do anything else with that. This one, we could factor out a z to get things started. So we'll factor out a z. We'll be left with z squared minus 4z plus 4. And this can be factored further. Because a is equal to 1, we can use the shortcut, find two numbers that multiply to 4 and add to negative 4. And that would be negative 2 and negative 2. So I'm sorry, my z's look like 2's. I apologize for that. So this is z minus 2 times z minus 2. But the thing you have to be careful about here when you are doing LCM is, remember, the last step is raise each factor to the highest power that occurs, which means exponents are important for finding the proper LCM. So anytime within a single expression, if you get the same factor twice, you need to write that factor as a square. Or if you get the same factor 3 times, you need to write it as that factor to the third power, if it's within the same expression. You cannot combine factors together from different expressions. So if we go back to the previous example, we had r minus 8 3 different times, but that doesn't mean we have r minus 8 to the third power, because these are all in separate factors. Sorry, they're not in separate factors. They're in separate expressions, right? So because they're separated from each other in separate expressions, they do not get to combine together as an exponent. But if they occur within the same expression, like we're having here, these are both within the same expression, you need to write that using an exponent. All right, so this is what we get for the second expression. The first expression looks like this. And now we want to find the LCM. So we have it factored. That's the best we can do to factor it. You take each factor that occurs. We have z as a factor in both of these. All right, so I'll have z here. We have a z squared plus 4 as a factor. And we have a z minus 2 as a factor. So take each factor that occurs and then raise each one to the highest power that occurs. The highest power of z is 4. So we need to have z to the 4th in our LCM. The highest power of z squared plus 4 is 1. It's just to the first power. The highest power of z minus 2 is 2. And if we didn't write this using exponents, we would think it was 1. All right, so it's really important if you have the same factor twice in the same expression to write that using an exponent so that you get the right exponent here in the LCM. All right, so that would be the LCM, or the common denominator. All right, so let's move on to the actual title subject matter for this section, adding and subtracting rational expressions. The first step will be to factor all of the denominators. You want to do this first for two reasons. First of all, to find the common denominator, which is the LCM, you want to have things factored. So this will help you for finding the LCM by having all the denominators factored. And then once we figure out what the common denominator is, we have to build our fraction up to match that common denominator. And that's also more easily done when your denominators are factored. So factor the denominators first. Then find the LCM of all the denominators. This will be your common denominator, just like we were doing on the previous examples. So step 2 is what we were just working on for the last few examples. Then once you identify what the common denominator is, get each denominator to match the LCM, match the common denominator, by multiplying in missing factors. So your denominators will already have some factors, but they'll be missing some factors from the LCM. So whatever factors your denominators are missing, that's what you want to multiply to those denominators so that they will match the common denominator, the LCM. And again, if that sounds hard to follow, we're going to do some examples, so you'll hopefully get to see how that works when we do the examples. Step 4 is once you have the common denominator, you can go ahead and add or subtract the fractions by adding or subtracting the numerators. The denominator will stay the same. So you have to have the same denominator to get started with that. And once you add or subtract the fractions together, the denominators will stay the same. You simplify the numerator, and then you try to reduce the fraction if possible, which means trying to factor it to see if anything will cancel out. All right, so this is a really very tedious, complicated problem. It has a lot of steps. I think it's one of the most complicated problems in the course in intermediate algebra. So don't feel bad if you're struggling with it. It's very common. It's a tough problem to do. So let's take a look at an example. Now, starting out, we're going to be given fractions that already have a common denominator. So these are actually not too bad. The denominators are already the same, so I can skip the first 3 steps, right? I don't need to factor. I don't need to find the LCM. I don't have to get my denominators to match the LCM because they already match each other. I can go right to step 4, which is let's just go ahead and add or subtract these fractions together. In this case, we're adding. So what we'll do is we'll take the first numerator, which is 2x minus 4y, plus the second numerator, which is 2x plus 11y. The denominator stays the same. It has to be the same to begin with, and when I add the 2 fractions together, it doesn't change. The common denominator stays the same in my answer. So whatever the common denominator is, that becomes the denominator of my answer as well. So we just put x plus y here. You don't add the denominators together, so be careful about that. So now I'll go ahead and combine like terms. We have 2x plus 2x, which will be 4x. We have negative 4y plus 11y, which will be positive 7y, over x plus y. Remember our training from section 5.1. You cannot cancel out terms. You can only cancel out factors. So the only way I can get this to reduce is if I can factor it, but it doesn't factor, right? 4x plus 7y is not factorable. And it doesn't match my denominator, so it's not going to cancel out with anything. So this is already reduced. Nothing here can cancel out. If you want to cancel out an x, you have to be able to factor the x out in order to cancel it out, and you can't do that. So it's already reduced. There's nothing else we can do with it. All right, so that one wasn't so bad. So if they give you fractions that already have a common denominator, that really helps a lot. Here they almost do, and it's an easy fix. We can actually get these denominators to be the same without actually having to go through the whole process that we talked about earlier, because they're pretty close to already being the same, right? We have y squared here, we have y squared here, we have 64 here, we have 64 here. The only difference is the signs of these terms. This y squared is positive, this y squared is negative. This 64 is negative, but this 64 is positive. So they're really the same, but they're off by the signs, right? One's the negative of the other, essentially. And whenever that's the case, this can be easily fixed. All you have to do, I don't know the best way to think about this, actually. Why don't we just do it this way? All you have to do is, there's a couple ways you can think of doing this, and I usually do the other way, but I'm going to do this time. To change the sign of both of these terms, all you have to do is multiply by -1. And that will make the y squared positive, it'll make the 64 negative, so then it'll match the first denominator. But if you multiply -1 to the bottom, you got to multiply -1 to the top to balance it out. Right, so the first fraction I'm not messing with. It's going to stay the same. 3y minus 24 over y squared minus 64. Minus, here I'm going to distribute this negative sign to the numerator, so I'll get -8 plus y on top. And on the bottom, I'm going to get -64 plus y squared when I distribute the -1 there. All right. And then I'll just flip these around so they look more normal, so that it's, from highest to lowest power, the way we're used to seeing these kind of expressions. So again, I hate to have to copy this down again, but I'm going to. Minus, we'll put the y first, the -8 second. And on the bottom, we're going to put the y squared first, the -64 second. And now you can see by putting them in the same order, these are now identical to each other. So again, this trick only works if they're already the same terms, but they're just opposite signs from each other. That's the only time this trick will work. All right, so now that we have a common denominator, let's go ahead and subtract these fractions. We'll take the 3y minus 24 minus the y minus 8. Now you got to be careful here. I kind of gave away what you have to do. I didn't mean to do that so fast. You want to subtract everything that's in the second numerator, right? So you want to subtract the y minus 8. And because there's two terms there, we want that minus sign to apply to the whole thing. So we really need to use parentheses around that. And what will happen is you'll distribute the minus sign to both of those terms. We'll do that in just a second. And then the denominator doesn't change, right? The denominator will just be y squared minus 64. Okay. So now to simplify the numerator, we'll start by distributing the negative sign. And so we'll have -y plus 8 here. We'll combine like terms. So I'll have 3y minus y, which is 2y. -24 plus 8, which will be -16, over y squared minus 64. And before you celebrate that you got through this fairly difficult problem and you subtracted it and you're at the end, the last step is, can you reduce it? And this one, it's possible, right? The last problem, we kind of got to dismiss that last step because nothing could be factored. And if nothing can be factored, nothing can be reduced. But here, things can be factored, right? So for example, the numerator, we could factor out a 2. And that's going to factor as 2 times y minus 8. On the bottom, this fits the a squared minus b squared formula again. This is going to factor as y plus 8, y minus 8. And, somewhat surprisingly, we do actually have two factors that are the same, so they'll cancel each other out. And I say surprisingly because for most of these problems, they most often won't reduce. Even though that's the case, you still have to check. So 9 times out of 10, you're going to factor these things and nothing's going to cancel out. But you're doing it because 1 out of every 10 times, you will find something and you have to reduce it. And so what we're left with here is a 2 on top and a y plus 8 on the bottom. All right. And we don't need the parentheses around that anymore. So, okay, very good. So let's take a look at a problem where we have to kind of go through, I guess maybe not all the steps, but more of the steps than what we just did here. Because again, here we essentially already had a common denominator, so we didn't have to do the LCM. This one, we do have to do the LCM. But the step that we end up not having to do, the reason I had to kind of modify my statement, is because we don't have to factor anything, because nothing here can be factored. We have w plus 4 as our first denominator. Well, that can't be broken down into any smaller factors, so w plus 4 is its own factor. So if you can't break it down into smaller factors, then the whole thing is its own factor. So w plus 4 is the factor of the first denominator, and there's nothing else there. And the w minus 6, again, cannot be factored, so that makes it its own factor. So the factor here is w minus 6. So to find the LCM, since we can't factor these things down any further, we'll just work with what we have here. We'll find the LCM by taking each factor that occurs. Well, the only factor in the first denominator is w plus 4. And because there's two terms and some other stuff is going to have to go here, we got to put parentheses around it. And the only factor in the second fraction is w minus 6. And so that also needs to go in my LCM, right? So to find the LCM, you take every factor that occurs. W plus 4 is one factor, w minus 6 is another factor. So both of those factors need to be in my LCM. And it's hardly ever going to apply at this point, but I'm still going to say it every time. Raise each factor to the highest power that occurs, but these are just to the first power. So we'll just leave them the way they are here, right? They're already to the first power. So this is my LCM, which means this is my common denominator. This is what I want my denominators to look like. I want to make both of these denominators match up to this so that they will be the same, so that I can then add these fractions together. So take a look at this fraction. You already have the w plus 4 here, but what you want is this. So the way I like to frame it is, here's what you already have, but here's what you need, or here's what you want. I don't know which word you want to use there for that. You already have the w plus 4, but this is what you need to have. So what you're missing is the w minus 6. That's not here in this denominator. Since that's the one that's missing, we're going to multiply it to that denominator, so it's not missing anymore. So I'll take w minus 6 times this first denominator. If I do that to the bottom of the fraction, I got to do the same thing to the top. So I have to also multiply w minus 6 to the top. So what I'm going to get here is I'll have w minus 6 times w minus 2. I'll have to go ahead and put parentheses around these since I'm multiplying something else to them. So I'll have that on top. And on the bottom, I'm going to stick with the same order that I have for my LCM. So I'll put the I'll put the w plus 4 first and the w minus 6 second. The order of those doesn't really matter, but I just want to be consistent. Since that's the order I have here, I'll keep these in the same order. For the second fraction, so let me go ahead and do this. There's a plus sign here. Let's go ahead and write that down. For the second fraction, I already have the w minus 6, but what I'm missing is the w plus 4. So since I'm missing that, I'm going to multiply it to that. So we'll multiply the w plus 4 to the second denominator, so now it has all the factors it's supposed to have. If I do that to the bottom, I'll do the same thing to the top to balance it out. So on top we'll have w plus 4, that's the w plus 4 that was already there, times this w plus 4. All right. Over, on the bottom we will have, I'm going to go with the same order up here, which is w plus 4 first, w minus 6 second. All right, so that was step 3. So step 2 was find the LCM. Step 3 is build your fractions up so that the denominators match the common denominator. And that's what we just did here. We looked at what factors do we already have, and then we multiplied the factors that we were missing. So we look at what do we have, what do we need, and you multiply the factors that you need to the denominator to make it match the common denominator. All right. Whatever you multiply to the bottom, you got to multiply the same thing to the top. And now we have two fractions with the same denominator, so now we can actually add these together. So on top we're going to have w minus 6 times w minus 2 plus, because we're adding, w plus 4 times w plus 4. The whole thing will be over the common denominator, which is w plus 4 times w minus 6. So again, you don't add the denominators. The denominator just stays the same as the common denominator. All right, so this will just stay the same as what these two denominators were. And then we want to simplify, right? Now, you might be, and this is the danger. I like to do the problem this way, but there is a danger with it that some students run into, which is they see, well, there's a w minus 6 here in parentheses, and there's a w minus 6 down here in parentheses, and they think, oh, those just cancel each other out. But they do not, because even though this w minus 6 is in parentheses, it's still part of a term, right? Because we're adding these two things together. That makes everything in front of the plus sign a term, and you cannot cancel out terms or even parts of terms, even if they're in parentheses. It doesn't matter. If it's part of a term, you can't cancel it out. So to simplify this, what we need to do is FOIL this and FOIL this, and then combine like terms, and then try to refactor the whole thing altogether. So instead of leaving it like this, we need to combine the two terms together and then try to see if we can factor it. And so we'll FOIL this out, and I don't want to have to rewrite the whole problem, so I'm just going to do it right here. So you do first outer, inner, last, you'll get w squared minus 2w minus 6w plus 12. Right? Here you FOIL, and you'll get w squared plus 4w plus 4w plus 16. All right, so now I must have reached my limit of how much I can write, and it still behaves well, because now it's not capturing all my pen strokes. So I'll have to go a little bit slower. All right, so you get plus 4w plus 16. So we're going to add these together. So we'll just combine like terms. And so we're going to get w squared plus w squared. That's 2w squared. We're going to get negative 2 minus 6. That's negative 8. And then, so I guess let's do it like this. It's more writing, but we get minus 8w here. And oddly enough, again, this doesn't normally happen, but we get plus 8w here. And so these actually just cancel each other out. And then we'll take the 12 and the 16, which gives me 28. So I'll get plus 28 over the common denominator of w plus 4 times w minus 6. And then I try to reduce this. So from here, I try to factor it and see if any factors match up that I can cancel out. And there is a little bit of factoring we can do. Because these both have even numbers here, we could factor out a 2. And that would leave me with w squared plus 14, which isn't going to factor. And none of the factors are going to match up, so it's not going to reduce. So even if I do factor out a 2, nothing's going to cancel out from that. So it's not worth doing. So this would be my final answer. And like I said, 9 times out of 10, it doesn't reduce anyways. But all right. So that's kind of how these problems that's how they become, right? So this is sort of worst case scenario. The only thing we didn't have to do here is we didn't have to factor out of the gate. And so let's take a look at an example where we actually have to do some factoring. But other than that, the rest of the problems are going to follow a pretty similar trajectory to what we just did. All right, so let's take a look. All right, now this one has 3 fractions for us to deal with, but it's not. I don't think it's going to add too much stress to us. The first step will be to factor all the denominators, right? And the v plus 1 cannot be factored, which means v plus 1 is the factor here in this denominator. The v minus 1 cannot be factored, which means v minus 1 is the factor here. But the v squared minus 1 can be factored. So I'm going to rewrite this whole problem. 11 over v plus 1 plus v plus 8 over, this will factor as v plus 1, v minus 1. Excuse me, v minus 1. Right, this is using the a squared minus b squared formula again, right? We've seen that a whole bunch of times already in chapter 5. And then this one's not going to change either because, again, it doesn't factor. So factor the denominators first. So that's the first step. And we actually had something to do this time with that. The second step is to, oops, I don't want to enumerate the steps here. Let's just write it out. Find the LCM of the denominators. So you take each factor that occurs. What are the different factors that I have in my denominators? I have a v plus 1. It occurs 2 different times, but I just write it 1 time for my LCM. And I have a v minus 1. Again, occurs twice, but we just need it 1 time for the LCM. And it doesn't apply in this case, but I still like to mention it. raise each factor to the highest power that occurs, but all these factors are to the first power, so these will be to the first power as well. So this is my LCM, which means this is my common denominator. All right? And so that's what I want all my denominators to look like. I want all my denominators to look like this. And the middle one already does. It's good to go. It already matches the LCM. It already is the common denominator. But I need to fix these other two. So this first fraction, we already have the v plus 1. So what are we missing from this denominator? We're missing the v minus 1. So since that's what I'm missing, that's what I will multiply to this denominator. I'm going to multiply it by v minus 1. If I do that to the bottom, I got to do the same thing to the top. So what I'll get is 11 times v minus 1 on top. And on the bottom, again, for consistency's sake, I'll go in the same order. We'll have v plus 1, v minus 1. I just take those same two factors, but I'll put them in this order instead. And I did the same thing with this because we're going to distribute the 11 eventually, but it's nice to have the 11 in front of the parentheses, so that's what I did there. Here, I don't have to make any changes because we already have the common denominator for this one. And so that'll just stay the same. For the last one, we already have the v minus 1, but we're missing the v plus 1, so that's what I will multiply to it. And if I multiply v plus 1 to the bottom, I got to multiply v plus 1 to the top. So on top, I'll have 4 times v plus 1, and on the bottom, I'll have v plus 1, v minus 1. All right, now all the denominators match. They're all the same, so I have a common denominator all the way through. And so now I can add these three fractions together. The denominator will not change. It'll stay v plus 1, v minus 1. And on top, I will have 11 v minus 1 plus v plus 8 plus 4 times v plus 1. So I've added my fractions together. That's step 3. I can't remember the steps now. Step 1 was factor. Step 2 is find the LCM. Step 3 is get the common denominator. So step 4 would be go ahead and add or subtract your fractions. And then step 5 is to simplify. Again, just because it's in parentheses doesn't mean it cancels out. This is part of a term. We can't cancel it out with the v minus 1 in the bottom. So what we have to do is distribute, combine everything together, and then see if we can factor it to get something to cancel out. So we'll have 11v, let me just do it up here. Well, I don't know why I'm doing it like that. Let's see. Let's just do it up here. All right, let me pick a different color. So we're going to have up here 11v minus 11. And when I distribute the 4 here, we're going to have 4v plus 4. And then let's combine the like terms now. So we have 11 and then 1v. Let me redo that. We have a 1v here and then a 4v. So we're going to combine those together and we're going to get 16v. All right, so it'll be 16v. And then the numbers. We'll have a negative 11 plus 8. That's going to be negative 3 plus 4, which is going to be positive 1. So we get... I feel like I'm not writing very well here. Let's try that again. 16v plus 1 over v plus 1 times v minus 1. And again, this can't even factor. There's not even a common factor here. And if it can't be factored, it can't be reduced. So that's the end of the problem. All right. Let's take a look at, I think I have a couple more examples. Oh gosh, I have 3 more. All right, so let's take a look at this example. We have y minus 9 over 7y plus 28 minus y plus 7 over 9y minus 36. So the first step is to factor these denominators. And thankfully, it's not really difficult factoring. It's just common denominator, not common denominator, greatest common factor. Sorry, too many mathematical terms floating around in my head. So we can factor out a 7, right? And that's going to leave me with y plus 4, right? Minus, here we'll have y plus 7 over, here we can factor out a 9, and that also leaves me with y plus 4. And that's really nice because these factors are the same. That makes things a lot easier for us. If these were different, things would be a little bit more challenging. So, and you'll see why in just a second. So factor the denominators first, then find the LCM. And because we have factors that are numbers, that's why I chose this example, because we have numerical factors, not just variable factors. And that adds a little extra complication to the process. So, but we talked about it before when we did LCM previously. So for the variable factors, you take each variable factor that occurs. Well, there's only one variable factor here, which is y plus 4. So that's it. And you raise it to the highest power that occurs. Well, it's both to the first power. Then you do the numbers separately. So we have 7 and 9. And as I suggested earlier in the video, try to think of the smallest number that can be divided by 7 and also divided by 9. And the smallest number that can be divided by both of those would be 63, right? Which you can get by just multiplying them together, but that's not always how you get the answer, so be careful about that. But 63 can be divided by 7, 63 can be divided by 9, and it's the smallest number that can be divided by both. All right, so this would be my common denominator. This is the way I want both of my denominators to look. So I look for what do I already have here? Well, I already have a 7 and I already have the y plus 4. So the y plus 4 is good. We already have that. We don't have to worry about the variable part, but we need to get the numbers to match up. I have a 7 here, but what I want to have is a 63. So to make that a 63, I'll multiply by 9. And if I multiply by 9 to the bottom, I got to do the same thing to the top. So on top, we're going to have 9 times y minus 9 over 63 y plus 4. Right? So the 9 and the 7 will multiply together and give you 63. Minus, we're going to do the same thing here. We already have the y plus 4, so we don't have to worry about that. All we have to worry about is making this 9 into a 63. And I can turn the 9 into a 63 by multiplying by 7. And if I multiply 7 to the bottom, I got to multiply 7 to the top. So we'll get 7 times y plus 7 on top over 63 y plus 4 on the bottom. So now both of my denominators match the common denominator. Since they're the same, I can go ahead and subtract here. So let's go ahead and do that. We'll just continue up here. We get 9 times y minus 9 minus 7 times y plus 7 over the common denominator of 63 times y plus 4. Now you might be wondering why I don't like to distribute here, but that I wait until later in the problem to do it. And this is exactly the reason why. Because if you do it here, you might say, okay, this will be 9y minus 81, and you wouldn't be wrong, that's correct. Here you would say it's going to be 7y plus 49. And then when you go to subtract, you'll say you'll have minus 7y plus 49. That's incorrect. It should not be plus 49. It should be minus 49, because not only does the 7 have to get distributed here, but the minus sign has to apply to all the terms here as well. So that minus sign would also need to eventually get distributed. And it's easy to overlook if you've already distributed the 7. It's hard to notice that the negative sign should also be distributed. So I like to wait. And if I get to this point, it's very obvious to me that when I distribute the 7, that minus sign's got to go with it. Right? And I won't make that mistake as if I see it like this. If I distribute here, I could easily make that mistake of forgetting to distribute the minus sign. So that's why I like to wait to distribute, because if there's any minus signs there, I'll catch those at that time. Right? So let's go ahead and distribute. We'll get 9y minus 81 when I distribute the 9. Here we're going to get minus 7y minus 49 is what we should get. Combine like terms, and we end up with 2y, and I don't have my calculator with me. This will be 50 and 80, which is 130, so it'll be minus 130, really big number, over, which is kind of a good sign, over 63 y plus 4. It's a good sign because I want to try to reduce, and I could factor out a 2 here to try to reduce it, but the 2 will not cancel with the 63, and whatever I get from this is not going to match up to the y plus 4. So even factoring out a 2, nothing's going to match up, nothing's going to cancel out, so there's nothing to reduce. So we're done. All right. Let's take a look at, like I said, I have a couple more problems. I think I'm going to do this one, and I'm going to do both of them, obviously, but for the next one, I'm going to suggest that you try the problem first before I work it out. But for this one, I'm going to go ahead and do it, and I'm going to say maybe you should just go ahead and watch this one as well without trying it first. I don't know if there's anything unusual going on with this problem, but it looks kind of challenging. So first step is to factor. Thankfully, the factoring is not the most challenging kind of factoring, but it's a little bit more than what we've been doing on the last couple of problems. We can use the shortcut because a is equal to 1, right? We have a 1 here. So we just have to find two numbers that multiply to 36 and add to negative 13. And that will be, let's see, two numbers that multiply 36 and add to 13, 9 and 4, right? So negative 9 and negative 4 gives me positive 36, but when I add them together, I'll get negative 13. And we will still have the 5w on top, right? So just factoring the denominator, minus, we'll have the 4w on top here. Same thing on this one. We need two numbers that multiply to 45, add to negative 14. That's going to be negative 9 and negative 5. Right? Negative 9 times negative 5 is positive 45. Negative 9 plus negative 5 is negative 14. And this is pretty common that when you factor things like this, they'll usually share at least one thing in common to help to keep things from getting too out of control. Right? So that's the first step, is to factor. The second step is going to be to find the LCM. So we take each factor that occurs. So we have a w minus 9, we have a w minus 4, and we have a w minus 5. Right? So looking at all the factors that I have in my denominators, here's a list of all of them. We raise each one to the highest power that occurs, but everything's to the first power, and so I'll just leave these to the first power. And so that's my LCM, which is my common denominator. This is the way that I want all my denominators to look. So I check out my denominators. I say, okay, what do I already have, right? So looking at the denominators here, we already have the w minus 9 and the the w minus 4. We already have those two. What we're missing is the w minus 5. Since that's what I'm missing, that's what I'm going to multiply to it. I'm going to multiply w minus 5 to this denominator so that it will match the common denominator. If I multiply that to the bottom, I got to multiply the same thing to the top. So multiply w minus 5 to the top. And so what we're going to get is 5w times w minus 5. I'm sorry, I feel a little bit distracted because I see I'm going to run out of room on this problem. This is already taking up too much space, and I don't have a plan for that. So let's see what I end up doing here in just a few minutes. Minus, do the same thing here. What are we missing from this denominator? We're missing the w minus 4, right? We have, let me use a different color here. We have the w minus 9. We have the w minus 5 already. What we're missing is the w minus 4. So that's what I'll multiply by. Multiply the same thing to the top to balance that out. So on top we'll have 4w times w minus 4 over w minus 9, w minus 5, w minus 4. All right, so now that we have a common denominator, we can subtract these fractions together into a single fraction. So I know that sounds weird to say subtract together, but that is what we're going to do. And so the denominator will stay the same, right? So my denominator will stay w minus 9 times w minus 5 times w minus 4. And then on top, we'll go ahead and do our subtraction with our numerator. So we'll have 5w times w minus 5 minus, let me try that again. Just always seems to make, whoops, hit the wrong button. I don't think I can undo it now. I'll have to do my eraser. Sorry about that. I hit the wrong button and then I hit it. I didn't just hit the wrong button once. I hit it like several times, so I'm sorry. Okay, let me focus again. Okay, so minus, we'll have 4w times w minus 4. All right, and again, I wait to distribute, and this is another case where it's good to do because you have that minus sign there, so now you can see when you distribute the 4w, the negative sign will have to go with it. So I might be able to fit this on the screen, but it's already starting to get a little bit laggy on me. So we'll distribute the 5w here, so we'll get 5w squared minus 25w. Here we're going to distribute the negative 4w, so we'll get minus 4w squared plus 16w, right? Because we're going to distribute the negative with the 4. Combine those together, and yeah, I don't know. I could try to squeeze it down here, or I could maybe just put it up here. But then I have a feeling this can actually be reduced. So it's going to be an extra. I need at least 2 more steps I need to do here. So I'm going to pause the video for a moment, see if I can do something to get myself some extra space, and then I'll resume here in just a second. Okay, so I think I found a solution to the space problem here. My first idea was to highlight this and copy and paste it, which worked, but it didn't let me put it where I wanted to. It just pasted it to the same part of the screen on a new screen, which means it would have been in the lower right-hand corner, which I didn't want. But I just wanted to show you what it looks like when I highlight it, and it explains why this gets so laggy after I do a little bit too much writing. So when I was highlighting it, whoops, oh, that's kind of weird. I didn't know I could do that. You can just see all the like individual elements that this thing has. It's a ton of them, right? So even, I don't feel like I really wrote that much there, but it records each mark separately, each pixel separately. I don't know, but there's so many different things here. And so I copy and pasted that, but like I said, it didn't work so well. The other thing I was able to do was do a screen capture. So I just kind of took a picture of this snippet of the screen right here, and I put it on a new page. So that's what I did. And that left me with this. So now I have plenty of room to work. So let's go ahead and continue from here. So what we want to do is combine like terms. Let me switch back to the pen tool. All right, so we have 5w squared minus 4w squared, which will give me 1w squared, right, positive 1. And then we have negative 25w plus 16w. That's going to give me negative 9w over the common denominator of w plus 9. Sorry, why do I keep saying plus? W minus 9, w minus 5, w minus 4. And this is one of those rare instances where this actually will reduce. So like I said, 9 times out of 10, the final answer you get doesn't reduce, but this one does, right? So what we can do to factor the numerator is we can factor out a w. It's just the greatest common factor. Factor out the w, and that leaves you with w minus 9, which just so happens to match a factor in the denominator, right? So we have a w minus 9 in the denominator. I almost said plus again. I don't know why I keep wanting to do that. So we have a w minus 9 on top. We have a w minus 9 on the bottom. So they actually will reduce. They cancel each other out. So my final answer is w over w minus 5 times w minus 4. So it's really important that if it does reduce, that you catch that. And the only way you can catch it is to try to factor things and see if any of the factors are matching up. All right, so we have one more example. I know this video has gone on quite long. Usually I take a couple of days to cover this material in my face-to-face class. So that's why it's kind of a long video. Here is the last example that I have for you. So if you will, pause the video, give this problem a try. It actually looks kind of tough too. I think maybe even harder than the one we just did. I'm sorry about that. But I want to make sure to do examples of all the different difficulty levels of problems that you'll see on your homework. So give this one a try, then resume the video if you get stuck or if you make it all the way through just to see if you came up with the same answer. So what you're going to have to do first is factor the denominators, right? So we'll factor this. This factors as w minus 7 times w plus 3, right? Two numbers that multiply to negative 21 and add to negative 4. Right? The numerator, we don't bother with factoring at this point, right? So we'll just leave it. Not that they could be factored, but even if they could, you wouldn't bother with that. You just factor the denominators for right now. This is the a squared minus b squared formula again. This will factor as w plus 3, w minus 3. So you factor first. The LCM is made, it's composed of all the factors that you have in your denominator. So we'll have w minus 7, w plus 3, and w minus 3. Those are the factors that occur in my denominators. Raise each one to the highest power that occurs. Everything's to the first power, so it'll stay as is. That's my common denominator. I'm not going to write that again, but you should know by now the LCM is your common denominator. So you want to make the denominators of your fractions match the common denominator. So you see what you have, see what you want, and whatever you're missing, you multiply to the denominator, so you're not missing it anymore. We have the w minus 7. We have the w plus 3. What we don't have is the w minus 3, so that's what I will multiply here. Do the same thing to the top to balance that out. Because we're multiplying something to this numerator, and it has two terms, we're going to have to go ahead and throw some parentheses around that as well. And so we're going to end up with 5w minus 1 times w minus 3 over the common denominator. W minus 7, w plus 3, w minus 3. And I'll just stick with the same order that I already had up here. Minus, because we're subtracting, because why not make it as hard as possible by having it be a subtraction instead of addition. Let's do the same thing with the second fraction. we have a w plus 3. We have a w minus 3. What we don't have is the w minus 7. So that's what I will multiply by. We'll do the same thing to the top. Make sure you put some parentheses around the w minus 6. So I'll have w minus 6 times w minus 7 on top. On the bottom, we'll have the common denominator, and I'm going to write it in the same order that I have here. So I'm going to put the w minus 7 first, the w plus 3, w minus 3. So now we have a common denominator in both of our fractions. We can go ahead and subtract these into a single fraction. So we'll have 5w minus 1 times w minus 3 minus w minus 6 times w minus 7 over the common denominator, w minus 7, w plus 3, w minus 3. So again, nothing cancels out just yet. I want to rewrite the 7. I was kind of bugged with that, so let's rewrite this last one here. Nothing cancels out. Even though those things are in parentheses, that's not enough for things to cancel out. They have to be factors, not parts of terms, and these are terms right here. So you can't cancel anything out here because they're terms, they're not completely factors. So what we need to do is multiply this out, and I think I will move this to a new screen so that it won't freeze up on me or get laggy. So let me go ahead and copy this. We'll paste it to a new screen, and we'll move it up here in the corner so that we have enough room to work. All right, so we're going to FOIL here. We have to do first, outer, inner, last. So when we FOIL this, we'll get 5w squared minus 15w minus 1w plus 3. Right. Here we'll have a minus sign, and then we have to FOIL this. We'll get w squared minus 7w minus 6w plus 42. But we want to subtract all of that, right? This minus sign is saying subtract whatever this is equal to. We want to subtract all of this from this over here, which means we need to use parentheses again. And so we'll have to distribute the negative sign. So let's just kind of rewrite all of that down here. We have 5w squared minus 15w, and I'm sorry, this looks bad, but it's a minus 1w, which is just w, plus 3. Then we distribute the negative sign here. So we'll have minus w squared plus 7w plus 6w minus 42. And then we'll combine all these like terms, and then I'll write the denominator here in just a minute when we get near the end. So we'll have 5w squared minus w squared, that's 4w squared. We have minus 15 minus 1, that's negative 16w, and then plus 13w. So altogether that gives me minus 3w. And then we'll have plus 3 minus 42, that's going to be negative 39. The whole thing will be over the common denominator of w minus 7, w plus 3, w minus 3. And then, unfortunately, I'm ready to be done with this video. I've been recording for an hour, more than an hour, because I've had to pause it a few times. But we have to check to see if maybe this can be factored, because it's possible that one of the factors might match a factor in the denominator and it can be reduced. So we have to at least look into it, right? And so if we're going to factor this, it would factor by the AC method. So A times C would be 4 times negative 39, which I'm not even sure what that is off the top of my head. Let me see if I can get a calculator real quick. I don't know if I have one handy. No. All right. Sorry, I should have paused the video again, but I didn't. I'll use my cell phone. All right. So 4 times 39. I probably could have figured this out if I just took a moment to think about it, but my brain's kind of fried right now. So we have negative 156, right? And B is equal to negative 3. So we need two numbers that multiply to negative 156, add to negative 3. So we probably should just make a list because there's a chance that nothing works. So it could be 1 times 156, 2 times 78, 2 times 78, right? Which obviously doesn't add to 3. Does 3 work? Yes, 3 works. Let's see, it'll be 5 and 2, 52. 4, Oh, 4 goes in, I think 4 does actually. So 4 goes into 15 3 times. Oh, of course, 4 and 39, because that's how we got 156. 5 doesn't work because it doesn't end in a 5 or a 0. Does 6 work? Well, if 3 works and 2 works, 6 works. So we have 6 will go into that, 2, and then we'll have 3, 36, 26. So 6 and 26, which also does not add to 3. 7 doesn't work. I think 8 works. I think it'll be 8. I don't know. Does 8 work? Actually, maybe it doesn't. Let's see. So 8 goes into that 1 time, and then you'd have 76. No, 8 does not work. I apologize for that. So 8 doesn't work. Does 9 work? Let's see. 11, 12. No, 9 is not going to work. 10 doesn't work. 11 doesn't work. I don't know if 12 works, but I know 13 does, because I know 13 and 9. So I think it's 12 times 13, actually. And the reason we're having so much trouble with this is because nothing actually gives us what we're looking for, right? It's, none of these are going to add up to 3 or to -3 or subtract to give me 3. And if you can't find any number, if you look at every possible, I shouldn't say if you can't find it, but if you've looked at every possible pair of numbers that will multiply to 156 and none of them will add up to 3 or subtract to 3, then it can't be factored. So I know that's a lot of hassle. Now what you can do on your homework is just use Math Excel, type it in, and if it tells you you're wrong, or if it tells you you have the right answer but you need to reduce it, then you'll know. But on the test, unfortunately, this is the only way you can really be sure, is to take the time to try to factor it, and maybe it doesn't factor, like in this case. So this is not possible, which means this can't be factored, which means it can't be reduced. And so this would be our final answer. All right, so that concludes the video on section 5.2, which was on adding and subtracting rational expressions.